Hey guys, how are you? We are going to work on just finishing up our conjugate roots and things like that. So in class on Tuesday, we didn't get as far as I had hoped, but I do want to do another example. The worksheet that I'm looking at is the one that does not have the heading on it. I was calling it the nameless or the headingless worksheet. It's the one that has all the letters, as opposed to this other one that we had been doing that does have that title up there, polynomial and conjugate roots. So I want the one that does not have the heading, and the one I'm on the side that only has rational or irrational solutions, not the imaginary, which is on the back of this sheet. So, and we are specifically going to be looking at letter H. I just wanted to do one more of these. In class the other day, we finished problem number 12, but we didn't get much further than that. So I just want to do one more of these because, again, I do feel like they can get a little bit complicated. So if you remember that when we do these, the first thing that we should look for is to make sure that there are not any irrational roots that they have not given us. Because again, sometimes on that other sheet that we did, the one that says polynomial and conjugate roots, they gave us some of the solutions, but not all of them. So again, think for a minute, how can we tell whether there's anything missing here? All right, so hopefully you're saying I'm looking for an irrational root and its conjugate, right? So as we look at this, oh, I see 1 plus square root of 2 and 1 minus square root of 2 combined into 1, so that is a complete pair. I got both the positive and the negative version there. And then I look at square root of 3 and I see that they did also give me both of them, positive and negative. All right. So there are no irrational solutions that are missing. They've given me both pairs, one root and its conjugate, one root and its conjugate. All right, so then we're ready to start doing to list the factors. All right, so this is the 0. So I'm going to write that as 1 plus square root of 2, and then x equals 1 minus square root of 2. I'm going to take up all this space just so that, well, because I can, because I printed out a blank copy for myself. You might want to do it on a separate sheet of paper. Because it's going to take up a lot of room. And then the third one would be x equals square root of 3, and then the fourth one would be x equals negative square root of 3. All right, and then the next thing is that we bring this over to the other side, so we get x minus 1 plus square root of 2. Again, remember, we're going to keep this in a parentheses, and we're just going to have a minus there, so we see what the actual 0 is in there. We don't change the signs. Then I'm going to do the same thing, x minus 1 minus the square root of 2. And then I've got x minus the square root of 3. Since it's a monomial, I don't have to worry about parentheses. And then x plus square root of 3. And again, while multiplication is commutative, and you could really put these in any order that you want, I'm going to encourage you strongly to put them as pairs side by side, because that is how you're going to want to multiply them together. If you don't multiply them together, like for example, if you decided to multiply these two together first, you are going to end up with a hot mess. So just to make your life easier, please do these conjugate pairs together and then do these pairs together. As soon as you do this one, you're going to get a really nice looking polynomial. And same thing here, you're going to get a really nice looking polynomial, all with integer coefficient, so we don't have to worry about any square roots anymore. So do these two together first and these two together as a pair. Okay, so let's do this one. And again, if you remember the pattern that we talked about, we said that when we're multiplying two polynomials together, if I do something like x minus 3 times x plus 8, that middle term, again, we would get x squared, this would be plus 8, x, this would be minus 3x, and this would be minus 24. That middle term, that x squared plus 5x, comes from the sum of these two. And then this last term comes from the product of these two. So we're going to take advantage of that pattern, and we're going to use that when we multiply out, so that we're not going to be multiplying each of these things together. We're just going to find the sum and the difference. So we FOIL, we get x times x is x squared. Then we're going to have a coefficient that belongs to the x, and then we're going to have some constant at the end here. Again, following that same pattern that we do. Sorry, you probably couldn't see it when I just multiplied that out. It was too low. But this, I said, came from the sum of these two. This came from the product of these two. So just as we did here, we're going to have a coefficient of the x, and we're going to have a constant. That's what I have these two blanks for. All right. I also remember that this came from the sum of these two, so this blank is going to come from the sum of these two. I'm going to notice that I'm adding two negatives together, so I'm going to put a minus sign here, because when I add two negatives I get a negative. And here I'm going to fill this in with a product, but it's a product of two negatives, so I'm going to be adding that. Negative times negative is positive. All right, now let me do the actual sum here. All right, so off to the side here, I'm going to do 1 plus square root of 2 and 1 minus square root of 2. Those are the two things that we're adding together to get that middle term. These two will cancel, and I just get 2. All right, so in this spot, I'm going to write 2 because that is the sum of these. Right, now in this spot, this has to be the product of these two. So again, I'm going to go off to the side. I'll do up here. So this is 1 plus root 2 times 1 minus root 2. 1 times 1 is 1. This is negative root 2. This is positive root 2. Again, those should always cancel out because they're conjugates. And then I've got minus 2. 1 minus 2 just gives me negative 1, so this is going to be plus a negative 1. And that is the product of these two. All right, let's do that again for this one. All right, this is going to be x squared because it's going to be these. Then I'm going to have coefficient of the x term, and I'm going to have the constant term. All right, now I'm adding these two right here. Actually, this one's not as bad. We could just multiply this one out, but we could still use that same analogy that we did here, that the coefficient here is just going to be the sum of these two. Well, negative root 3 and positive root 3, those just give me 0. So this is going to be a 0. And then the product here, negative square root of 3 times positive square root of 3 gives me negative 3. Doesn't matter, oops, this should be an x squared. It doesn't matter what the sign of this is, either positive or negative. It's going to just, this term won't be here. All right, so again, I'm doing the same thing where I find the coefficient of the middle term just by adding them. And again, these are much easier because they're monomials. A negative root 3 and a positive root 3 give me 0. And here I multiply the two of them to get that. Negative root 3 times positive root 3 gives me negative 3. Now I just write this a little bit tidier, not quite as spaced out. So x squared minus 2x minus 1 times x squared minus 3. You might be looking at that thinking, wow, I totally didn't expect that to happen. But really you should have, because if you see it now, it should probably make sense. If I were to get two solutions as positive and negative 3, I could just use the square root method to solve this. Remember when we had x squared minus 3 equals 0? That I can add 3 to both sides, and then I take the square root, and I get x equals plus or minus 3. That's how we would have gotten that. So that's why we get that polynomial there as their product. Okay, so then let's just multiply it out. X squared times x squared, x to the 4th. X squared times negative 3, negative 3x squared. Negative 2x times x squared, negative 2x cubed. Negative x squared, negative 2x times negative 3, positive 6x. Then I do negative x squared and plus 3. And finally our answer is x to the 4th minus 2x cubed minus 4x squared plus 6x plus 3. Let me just double check to make sure that's what I actually got. Yep, that's what I got. Okay, my answer key. All right. So then I want to leave this sheet. Actually, this sheet should be completely done now. That was the last problem that was left. So then let's go back to the sheet with the heading on it. All right, if you remember, in class last time, we had just quickly done problems 1 and 5. All right, and again, this section, you're just supposed to say, what zeros did they not give me? So let's take a look at this one, because it's a little bit more complicated than these two right here. So let's see if there are any zeros or solutions that they did not give us. All right, so again, there are imaginary numbers here, but it's really just the same as irrational, because remember, I is the square root of -1, so it doesn't look like there's a radical in this, but really there is. So we're just doing the same thing. We're looking at a zero and we're saying, is its complex conjugate, or you could just say conjugate, is its conjugate included? All right, so I look at -3 plus 2i, and so I'm looking for its conjugate, -3 minus 2i, to be in the list. Nope, it's not either of those, so then I have to write -3 minus 2i. Right, I go to the next one and I say -2 minus 2i, so I know its conjugate must be in the list, and I look to see, yep, it's already in there. So the only one they did not give us was this one right here. All right, okay. Again, I know for homework that you had to do some of these problems, but I just want to do one of these together and then go back to the other heading list sheet and do a couple on there. So for problem number 8, right, the first thing I'm going to do, again, this sheet was less good about giving us all the solutions. We had to find one, so we had to find missing ones. That's not so true on the other one, where they generally gave us all of them. But I look here and I say -1, is that irrational or imaginary? Because we only have irrational and imaginary theorems about the conjugate root. So this is not, it's rational, right? It can be written as a fraction, -1/1, and therefore it doesn't fall into those other categories. There is no buddy that goes along with this guy. I can't say +1 also has to be a solution. That's not true. Rational roots do not come in pairs, right? So this is enough as it is, but then I look at this, the -i, and I say, yes, that is imaginary. Therefore, its conjugate must be included, which I don't see. This is the last thing on the list. So I have to say that I know that also regular I, not -i, should have been on that list. All right, now I go through and I start writing my zeros. So x equals -1, x equals -i, x equals +i. And then I'm going to rewrite this as x plus 1. And this is going to be x plus I and x minus I. And again, the temptation might be to just take those first two, since we tend to read from left to right, but resist that urge. Always do the conjugate pairs together. All right, so I'm going to take and multiply these two together. All right, so I've got x squared. And again, if we follow that same pattern that we were just talking about, I'm going to have a coefficient of the x and I'm going to have a constant. This coefficient is going to be the sum of the two constants here. So positive I and negative I cancel out. So this is going to be a 0. And then positive I times negative I is going to be -I squared. All right, I'll just put a plus in there. All right, and hopefully you remember, it's been a while since we've done this, but when there is an exponent on an I, we can always simplify it. So if you remember, I squared was -1, so we have minus a -1. So this ultimately ends up cleaning up to x squared plus 1. All right, I'm going to do that down here. So we've got this x plus 1 right here, and then this is going to simplify it into x squared plus 1. All right, now just multiply out. So x times x squared, x cubed. X times 1 is x. X times, 1 times x squared is x squared, and 1 times 1 is 1. And then we just arrange it in the proper order. X cubed plus x squared plus x plus 1. You know what I forgot to do in the last one is put that y equals. And so that is what the polynomial would look like to begin with. All right, so in this one I really should have written y equals that. Okay. Let's go back to, sorry, with all the switching around, we're going to go back to that same headingless worksheet that we did, but we're going to look on the back side. All right, so I just want to look at problems E and F, and I'm specifically choosing these two because of the ones that are left on the sheet. I think you've done A and C already. I'm picking the hardest of the remaining 4, and you're going to do these two on your own at home for homework. I think it's tomorrow. But anyway, I just want to do these two because I figure if we get the hardest ones out of the way, then you'll feel more confident with the easier ones. All right, so let's take a look at letter E. So we've got -4. Right, rational. So there is no buddy that goes along with that. It's just -4. He has no partner. And then here I've got 1 plus 2i and 1 minus 2i. Those two are complex conjugates, so I don't need to list any others. They gave me both pairs, or both things in the pair. All right, so next we say x minus 4. I'm sorry, x plus 4. Let me start over there. We say x equals -4. We say x equals 1 plus 2i, and x equals 1 minus 2i. Now I write this as x plus 4. Again, we have been writing x plus 4 equals 0, but I'm just going to multiply all of them together in just a second, so I'm going to ditch that part for right now. This is going to be x minus, because this is a binomial, I've got to put it in parentheses. Right, so this is x minus 1 plus 2i. And then we'll do the same thing here, x minus 1 minus 2i. Okay, again, I know I've written this one first, but don't be tempted to do these two together. Do these two together. All right, so I've got x plus 4, I'm just leaving them there. I've got an x squared, I've got a blank for the x coefficient, and I've got a blank for the constant. I'm adding together two negatives to put in that spot, so I know this is going to be negative, and I'm multiplying two negatives to put in that spot, so I know this is going to be positive. All right, the sum of these two, all right, I'm just going to add them. So 1 plus 1 is 2, and positive 2i and negative 2i are going to cancel out, so this is just going to be 2. All right, again, if you need to write it down, go ahead and write it down, but I'm just doing 1 plus 1 is 2, negative 2i and positive 2i cancel. All right, this part I will write down. I've got to do 1 plus 2i times 1 minus 2i, and when I multiply them out, I get 1, I get minus 2i, I get plus 2i, and then I get minus 4i squared. These cancel out. So I get 1 minus 4i squared. Again, you don't need to do that step right there. You could just say, oh, I squared is -1, so this changes it to plus 4. So it's going to be 1 plus 4. You could just skip that and write 5 if you would like. All right, so I've got x plus 4 times x squared minus 2x plus 5. All right, pause for just a minute, and I want you to multiply that out and come back and check your work. Okay, so here's what you should have done. X times x squared, x cubed. X times negative 2x is negative 2x squared. 4 times x squared is 4x squared. 4 times negative 2x is negative 8x. 4 times 5 is 20. So when we put the combine like terms and put it in order, we've got x cubed plus 2x squared minus 8x plus 20. And again, that equals y at the end. All right, hopefully you got that. Right, I'm going to do the work for this one, the 1 minus I, the 1 plus 3I down at the bottom. But first, let's just look to see if we're missing any solutions. So what do you think? Hopefully you said, yeah, I don't see this guy's conjugate. I also need a 1 plus I. I also don't see this guy's conjugate. I need a 1 minus 3I. This guy is rational. It doesn't get a partner, so it's just staying 0. So I have these 1, 2, 3 that were given, plus 2 more conjugates that I didn't give, for a total of 5. Right, and again, I'm going to come down here where there's more space and do this. So I'm going to write, and you'll just be looking up at yours here as I'm writing it down at the bottom. So I get x equals 1 minus I, x equals 1 plus I, x equals 1 plus 3I, x equals 1 minus 3I, and x equals 0. Now I'm going to go through this step where I change it. Instead of equaling that, I'm going to scooch it over to the other side. So x minus 1 minus I, again, because it's a binomial, I put it in parentheses. Then this is going to be x minus 1 plus I. This is going to be x minus 1 plus 3I. This is going to be x minus 1 minus 3I. And this is just going to end up being a plain old x. If I move that 0 over, it's just x minus 0, which is x. I'm going to put him all the way up at the front. Right? Now, again, don't do these two together. It's tempting because we want to go left to right, but do the conjugate pairs together. Do the conjugate pairs together. All right, so I'm going to have this x that's out front, just this guy right here. The next thing I'm going to have is an x squared. I'm going to have a coefficient of the x term, and I'm going to have a constant. That's going to be for this one. I'm going to do the same thing here. I'm going to get an x squared. I'm going to get a coefficient for the x term, and I'm going to get a constant. That's for this right here. All right, so let's go ahead and do that. Again, I encourage you to pause the video and see if you can do this on your own, and then you can just watch it and check to make sure you're right. Or maybe if you want to watch this part of it, and then when we get to this one, you pause it, you see if you can do it on your own. All right, so again, I'm going to note that the sign of this, since I'm adding two negatives, this has to be negative. And since I'm multiplying two negatives, this has to be positive. It's going to be the same here, right? That wasn't true when we were doing monomials like we did on the previous page, but it is true when we're doing binomials, that this is always going to be a minus and this is always going to be plus. Okay, for this middle one, I'm just going to add these two terms together, right? So 1 minus I and 1 plus I, we just end up with 2. Again, if you need to write it down, please do. You're just finding the sum of them. It's not always going to be 2. I know every example that we've done has been 2, but that's because they're just choosing a 1 right there. If this instead had been something like 7 minus I and 7 plus I, then we would end up with a 14 here. All right, it's not always going to be a 2, but just their choice of solutions has always had a 1 right there, and that's why it ends up being a 2. Okay, and then the next part that goes here is their product. So we're going to be doing, I'll do it right here, 1 minus I times 1 plus I, right? 1 times 1 is 1. This 1 times positive I and this 1 times negative I, those are going to cancel out, and I'm just going to end up with minus, because I'm doing a negative times positive, and then I times I, which is I squared. Again, we remember that I squared is negative 1, so this is 1 minus a negative 1, or 2. All right, so 2 is going to go in that spot. Again, we've done these already plenty of times before. It's just now we're seeing them as part of a bigger problem. So I just want to refresh your memory on that, that when we saw these before, we knew that those two middle terms would cancel out. But maybe you forgot now. All right, so if you remember, just don't worry about doing that whole thing. Just multiply it out with whatever shortcut you remember from before. All right, so then this one we do the same thing. This coefficient is going to be the sum of these two. All right, so when I add 1 plus 3I plus 1 minus 3i. The 3 i's cancel out because one's positive, one's negative. Again, we get a 2. Again, they've just chosen something that's a 1 right out front. And then we're going to do 1 plus 3i times 1 minus 3i. Right, 1 times 1 is 1. Again, this product, the 1 times the negative 3i, and this product, the 1 times positive 3i, will cancel out, so I'm not going to write them. But I will write this final product, negative 3i times positive 3i. That gives us negative 9i squared. Again, I squared is negative 1, so this becomes 1 plus 9. I almost wrote 10. 1 plus 9, which is 10. All right, so 10 goes right down here. All right, let me just write this a little bit cleaner. So it's x times x squared minus 2x plus 2, and then x squared minus 2x plus 10. Now it doesn't really matter what order you do them in. I'm going to choose to do these two again and then save the easy part for last, where I just distribute an x to everything. So if I do that, I get x times x, or I'm sorry, x squared times x squared is x to the 4th. X squared times negative 2x is negative 2x cubed. X squared times 10 is 10x squared. Now I do it for the negative 2x, so negative 2x times x squared is negative 2x cubed. Negative 2x times negative 2x is positive 4x squared. Negative 2x times 10 is negative 20x. Then I'm going to do it for the 2, which is, I'm going to run out of room here, so this is positive 2x squared, this is minus 4x, and this is plus 20. And then I still have this x out front. Let me clean up here. I get x to the 4th. There are no other x to the 4ths here, so just an x to the 4th. The x cubes, I have 2 of them. They give me minus 4x cubed. X squareds, I have 3 of them. I have a 10x squared, a 4x squared, and a 2x squared, so that gives me 16x squared. I'm just crossing them out so I make sure I've used up all of the all of the similar ones. All right, then I've got a negative 20x and a negative 4x, which gives me a negative 24x, and I have a plus 20. Right, I'm out of room here, so let me go on to a new piece of paper. All right, and now all that's left is just distributing that x through, and again, this is why I saved that part for the end, because it's so easy. I just increase all the powers on the exponents by 1, so this becomes x to the 5th minus 4x to the 4th plus 16x cubed minus 24x squared plus 20x, and then again, last step is just set it equal to y. And that's it. Oops, maybe you couldn't see any of that. All right, hopefully you did. I just combined everything here and got that. Okay, that's it. So you're going to work on some of these problems, and let me know if you have any trouble.